Every morning, the sun rises on one side of the sky. It travels slowly across and sets on the other side. One sun, one shadow. One simple rhythm that has governed life on Earth for 4.5 billion years. But what if there were two? Most stars in the universe are not alone. About half of all sun-like stars have a companion, a partner star orbiting alongside them, which means single star systems like ours might actually be the exception, not the rule. So let's give Earth a second sun, same size as our current one, close enough to see clearly in the sky. What happens next depends entirely on one thing: where exactly that second sun is sitting. Let's start with the most dramatic option. Two suns side by side, both close to Earth, both warming the planet at the same time. The first thing you would notice is the shadows. Every object on Earth would cast two of them, pointing in slightly different directions. Your shadow and your other shadow, walking beside you everywhere you go. Artists would lose their minds. Photographers would have to relearn everything. The light levels would be extraordinary, about twice as bright as a normal sunny day. Sunscreen would need to be reinvented. SPF 50 would become SPF 500. Sunglasses would be mandatory outside, not a fashion choice. A medical necessity. The temperature would rise dramatically. Earth already sits at the perfect distance from one sun. Add a second one at close range, and the average global temperature would increase by dozens of degrees. The polar ice caps would melt within years. Sea levels would rise by over 60 meters. Every coastal city on Earth would be underwater. London, New York, Tokyo, Shanghai, all gone. The tropics would become uninhabitable. Temperatures pushing 60 or 70 degrees Celsius. The kind of heat that kills in minutes. Life would retreat toward the poles. What used to be frozen tundra would become the new temperate zone. Canada and Siberia would be the most valuable real estate on Earth. But let's be more precise. The behavior of a two-sun system depends on the orbital mechanics. And orbital mechanics are ruthless. In a binary star system, there are two stable configurations. The first is called a P-type orbit. The planet orbits both stars together, from far enough away that both suns appear close together in the sky, like a very bright double star. This is actually the scenario scientists think is most likely for habitable planets. The second is called an S-type orbit. The planet orbits just one of the stars, while the second star orbits far in the distance, like a very bright second star in the night sky, sometimes closer, sometimes farther away. Seasons would become almost impossible to predict. In the P-type scenario, Earth's year would change completely. The gravitational pull of two stars would alter the orbital path. A year might become longer or shorter, depending on the exact configuration. Calendars would need to be rebuilt from scratch. The day and night cycle would also change. In some positions of the two suns, there might be no night at all. Both stars on opposite sides of the sky, one rising as the other sets. Perpetual daylight for weeks or months at a time. Plants would struggle to adapt. They evolved to use darkness as a signal, a trigger for certain biological processes. No darkness means no signal. Many species of trees and flowers would stop blooming entirely. Others might adapt over thousands of years, growing tougher leaves, developing darker pigments to handle the extra radiation. Sleep would become a crisis. Human bodies are wired to sleep when it gets dark. With no darkness, the brain would lose its rhythm. Insomnia would become epidemic. Societies would have to build underground sleeping chambers, blocking out the endless light, just to stay functional. Animals would be even more affected. Nocturnal species would have nowhere to hide. Owls, bats, and most deep sea creatures depend on darkness to survive. Without it, entire ecosystems would collapse. The food chain would restructure itself over centuries. Now here is the most interesting version of this scenario. What if the second sun were much farther away? Not a twin, more like a distant companion, orbiting our solar system from very far out. Some scientists actually think our sun might have a companion like this, a dim, cold, distant star. Too far to see, too faint to detect easily. They called it Nemesis. The theory suggests it periodically disturbs the outer solar system, sending comets raining inward toward the inner planets, possibly triggering mass extinction events on a cycle every 26 million years or so. We have not confirmed Nemesis exists, but we have not ruled it out either. The honest answer is this. A second sun close to Earth would make the planet mostly uninhabitable. Too hot, too bright, too unstable. A second sun very far away might already exist, and we might never know until it matters. But for one moment, imagine it. Two suns setting on the horizon, one orange, one pale yellow. The sky turning colors that have no names yet. Double shadows stretching behind you across the sand. It would be the most beautiful apocalypse you ever saw.